most of the reactions you're going to do in this class, you should be able to relatively easily predict. But the one that's going to throw you guys off is gas evolution. You are responsible for gas evolution reactions. You need to know what products will form. So you should be able to identify and predict products' various reactions, including double displacement, single displacement, synthesis, and decomposition reactions. But specifically what's going to cause problems is the gas production from a double displacement reaction. So neutralization reactions that produce a gas. The dissolved ions are actually going to rearrange in solution and form an unstable compound. That compound decomposes further to form a gas and water. And so if you see, when you are writing out your products, if you see H2CO3 form, H2SO3 form, or NH4OH form, you have to recognize that those will not stay in solution. They will further decompose, forming water and whatever's left. Now, you can either just memorize them all straight out, or what I have memorized is H2CO3, H2SO3, and H4OH, and I know they're going to produce water and something else. But again, if I see one of those products, I have to know that it further decomposes to form H2O and a resulting gas. Let's work a few examples. Write the complete reaction. So we've got calcium carbonate reacting with HCl. Well, I know calcium, Ca2 plus, carbonate, CO3 2 minus. So Ca, CO3, HCl, HCl. Now think about your solubility rules. You guys have them listed on the periodic table for this class, which can definitely help you. Take advantage of that. Use that to your benefit. When you look at carbonates are usually insoluble. Even with group 1 cations, they are actually going to be insoluble, but it will react with hydrochloric acid, so it will actually react. It's going to swap partners, forming calcium chloride. Again, chloride is a Cl minus, so I need 2 of them to vector out to the calcium. But it's going to form H2CO3, and this is what's important here. The moment I see H2CO3, I know this is going to actually further break down. So the actual products of this reaction, let me move this up here. The actual products here will be plus water and CO2. Now, you may wonder why is a solid reacting with HCl? Well, because HCl is an acid, and it's going to react that. Trust me, the hydrochloric acid can heat up the carbonate. But this here came from the other product, the H2CO3. Actually forms H2O and CO2. What if I have ammonium nitrate and sodium hydroxide? Ammonium, NH4 plus, nitrate, NO3 minus. So I get NH4NO3. Now that is completely soluble. Sodium hydroxide, Na plus and OH minus. So NaOH, that is also completely soluble because it is a strong base. When they swap partners, they're going to form NaNO3 and NH4OH. But I have to recognize that this NH4OH is going to further decompose, forming H2O, and what's left over is NH3. And that will be a gas. And sodium sulfite and hydrochloric acid, sodium sulfite, Na plus, and SO3 2 minus will give me Na2 SO3. Hydrochloric acid, HCl, aqueous, it's a strong acid, reacts, giving me NaCl, and I'll balance this out in just a sec, plus H2SO3. 2 here is going to balance this out. But I have to recognize that this H2CO3 actually further decomposes, forming H2O liquid and SO2 gas. So again, anytime I see carbonic acid, I know it forms water and carbon dioxide. If I see ammonium hydroxide, I know it forms water and ammonia gas. So if I see H2SO3, I know it's forming H2O and SO2.